Today, we will start with another interesting and learning episode of Forensic Pharmacology Part 1, divided in different modules. Module number 1, Basic Concept of Pharmacokinetics. Module number 2, Absorption of Drugs. Module number 3, Distribution of Drug. Module number 4, Metabolism of Drugs. Module number 5, Elimination of Drugs, and finally, module number 6, the conclusions. Okay, so speaking about pharmacokinetics, pharmacokinetics express the fate of a substance, specifically a drug of abuse, administered to a living individual. So pharmacokinetics represents how the organism affects a substance. This is the opposite of pharmacodynamics, which deals on how a substance affects a living organism. In pharmacokinetics, we can mention some parameters which can define different substances and different drugs of abuse. For example, the dose, which is the amount of an administered substance or an administered drugs of abuse. Then we have the Cmax, the peak plasma concentration of a drug after its administration. Then we have the Tmax, which is the time to reach the maximum concentration in blood. We have the volume of distribution, which is the apparent volume in which the drug is distributed inside the organism. So the volume of distribution is a ratio of an administered dose of a drug of a substance divided by a concentration in the bloodstream. Then we have the elimination half-life, which is the time required by a drug to reach half of the starting concentration inside the organism, so inside the bloodstream. When a drug is administered by mouth, perus, it reaches the digestive tracts, and at that point, usually at 20–30% of the drug is absorbed into the systemic circulation, so into the blood. This is for the drugs orally administered, but drugs can be also administered intravenously. Many drugs of abuse, for example, heroin, and they immediately enter the bloodstream, so we don't have the absorption, or we can consider the absorption at 100%. Also, the snorting, the sniffing of a drug means the 100% of absorption, and the bloodstream is reached in terms of seconds, so has the passing of hematoencephalic barrier and reaching the brain. Once the drug is absorbed, it is then distributed in the different organs, which are called the target organs. And if the drug is highly distributed, we speak about a high volume of distribution. If the drug is not, it shows a low volume of distribution. When we study the pharmacokinetics of a certain substance and the interaction inside the human body, we speak about the ADME cycle: absorption of the drug, distribution, metabolism, and excretion. These are the points touched by the pharmacokinetics of a drug. For each of these points, we have a biological matrix which we can analyze to define the absorption, the distribution, the metabolism, and the excretion of a drug. Indeed, some decades ago, it was only possible to analyze blood and urine to study the pharmacokinetics of a certain drugs. But with the passing of the years, with the new analytical method at disposition, and with the new available method of sample extraction, liquid and solid biological sample extraction, we could reach and study the different points of the ADME cycle. So we will see in each time the biological matrices involved in this cycle. Once a drug is in the bloodstream, it is immediately distributed to the target organs of the human body. If the volume of distribution is very high, this means that the drug is completely distributed to the target organs and it disappears from the bloodstream. But if the drug is not distributed to the target organs, for the chemical characteristic of the drugs and the pH of different target organs, we speak about a low volume of distributions. Many target organs can be studied for the presence of the drug with the possibility we have now at the moment. For example, for many snorted drugs such as cocaine or some other amphetamines, but also heroin, because heroin can be snorted, we can study the bronchial secretions, we can extract this matrix and see the content of the drug and the metabolites inside, because we can correlate this measurement with some problems, some respiratory problems or other side effects caused by the snorted drugs. We can also study, for example, the presence of the drug in bile to see the presence of this drug in the digestive tract, and also to study its eventual elimination by feces. We can also study, for example, the presence of a drug in aspirated air, like alcohol, once it was consumed by an individual, to relate it with a concentration in blood. We can also study saliva to see if the drug is still present in the bloodstream, because saliva is directly linked to blood, or if it is already distributed in the organism. A special case of distribution of drugs is the pregnant mother who distributes a consumed drugs or a drugs of abuse to the fetus. So we speak about the maternal fetal compartment, which has the placenta as a filter between the mother and the fetus. We can study the distribution of the drug between the mother and the fetus, studying placenta, but also examining amniotic fluid when this fluid is available, and that we can also study the distribution of the drug in the last day of the pregnancy or during delivery, examining the cord blood of the newborn. And also we can study the newborn hair to see the distribution of the drug from the mother to the fetus during pregnancy. Finally, another kind of distribution is the distribution to the breast milk when the baby is breastfed by the mother. So, examining the breast milk, we can study and measure the amount of drug passed from the mother to the baby, the fed baby. This is, for example, the case of nicotine. We can measure the nicotine from a smoker mother to the newborn, which is breastfed. Finally, to study the distribution of the drug during the second and third trimester of the pregnancy, we can examine the meconium, the neonatal meconium, which are the first feces eliminated by the newborn within the 24 hours of life. This biological matrix is a repository of all the drugs distributed from the mother to the fetus during the last 2 trimesters of pregnancy. And we can correlate this measurement with the clinical outcomes of the baby. One of the most important target organs reached by the bloodstream is the liver. In the liver, we have the metabolism, the transformation of the drug into metabolites. These substances are generally more hydrophilic than the parent drug. Why they have to be more hydrophilic? Because then they have to be eliminated basically through the kidneys into the urine, which is a water liquid, an hydrophilic liquid. Not only the metabolism is a transformation to more hydrophilic substances, but also to sulfate substances, different metabolites that sometimes can be more toxic than the parent compound. These are the phase 1 metabolites, and the transformation occurs to the enzymes of cytochrome P450, the different isoenzymes which metabolize in a different way the different drugs. So remember that in case we consumed more than one drug, and one of these can be an inhibitor of this cytochrome P450 group of enzymes, we can inhibit a metabolism of the drug, and so we can create a higher toxicity of some drugs. Also, the hepatic disease can block the metabolism of many drugs, and so we have to take and pay attention to this when we have to give a certain pharmaceutical or a certain medicine, or we are studying the effect of a drug of abuse. Drugs are usually eliminated through the kidney and versus urine. Urine is the aqueous repository of the drugs and the last point in the excretion of the drugs. But we have to say that some drugs are also eliminated through bile, especially the lipophilic drugs, for example, the cannabinoids. And then the bile goes directly to the feces by biliary excretion. Coming back to the elimination through kidney, it occurs through a glomerular filtration of unbound drugs. But in case of bound drug, we have an active secretion with blood transporter, specific transporter of bound drug through the kidney. Remember that in case of renal failure or renal diseases, this excretion is stopped. And so we can have cases of drug intoxication because excretion does not occur. Excretion of drugs is very easily studied through the analysis of urine. Remember that, speaking about pharmacokinetics, with the examination of urine, we can have no information regarding the pharmacokinetics of a drug. We can do any relation with dose, with the time of drug consumption. We can only say that a drug has been eliminated with its metabolites in urines. Sometimes we don't find the parent drug in urines. We only find metabolites, but they are the biological markers of the presence of the drug in the human body. In this specific topic, we spoke about the basic concept of pharmacokinetics and the ADME cycles of the drugs inside the organism. Before concluding this topic, I would like to spend some words regarding the different drugs of abuse and their pharmacokinetics inside the body. Heroin is usually injected or snorted. This means that it reaches the bloodstream in terms of seconds, and in terms of seconds, it also reaches the blood-brain barriers. But heroin is immediately transformed or deacetylated to 6-monoacetylmorphine. So, in terms of minutes, we cannot measure heroin in blood. We can measure 6-monoacetylmorphines, but this occurs just for 10 or 20 minutes. Afterwards, we will find only morphine in the bloodstream, because the deacetylation of heroin to 6-monoacetylmorphine and to morphine is immediate, and it occurs immediately in the liver. So, we can speak about the maximum concentration of morphine, but in reality, the drugs of abuse which acts on the brain is morphine, and just a little 6-monoacetylmorphine, not heroin. Regarding cocaine, cocaine is also snorted, and so also cocaine reaches the bloodstream and the brain-blood barrier in terms of seconds. Cocaine is also transformed in terms of minutes in benzoyl-ecgonine, which is an inactive metabolite of the drug. If we examine blood, after some minutes we found only morphine, but we still found cocaine with benzoyl-ecgonine. But if we examine urine, we will find just morphine and its glucuronides metabolites, and we just find benzoyl-ecgonine. We don't find cocaine. In case of amphetamines, they are orally administered, and their maximum concentration is reached in terms of 1 hour, 2 hours, and the elimination occurs in terms of 5 hours. So the effect is immediate in case of cocaine and heroin, and just 1 hour in case of amphetamines and all the other substances administered orally. Regarding cannabis, it is smoked. The psychoactive principle of cannabis, delta-9 tetrahydrocannabinol, is a very lipophilic agent. This means that we have an enterohepatic circulation that leads to the fact that we can find tetrahydrocannabinol in blood and in urine in terms of days, because he has a very enormous volume of distribution because of its lipophility. Alcohol is consumed orally and is absorbed into the digestive tract, and it reaches liver, where it is metabolized to acetaldehydes. But we have to remember that some individuals, especially from Asia, Japan, or China, they do not have the enzymes to metabolize alcohol to aldehyde. They don't have the aldehyde dehydrogenase. In this case, they have a very toxic effect because ethanol remained in their body, not being metabolized. In the other cases, we can measure alcohol in blood, but we can measure also alcohol in the expired hair, and the concentration found in the expired hair is totally related to the concentration in blood. We can also measure some alcohol in urine. This parameter is called alkoluria, but is not useful for anything. The most important pharmacokinetics parameter for alcohol is its presence in blood. GHB, one of the new psychoactive substances, gamma hydroxybutyric acid, is metabolized in terms of minutes. So after a few hours, you don't find this drug in bloodstream, nor in urine, and you cannot measure it. Also because since we have also endogenous concentration of this drug, the value goes to the baseline, and we have to consider it that GHB is at the endogenous concentration. Finally, for many of new psychoactive drugs, their pharmacokinetics is longer than the classical drugs. This means that they can have Cmax concentrations and times to reach the maximum concentration in terms of 3 or 4 hours, and the elimination half-life in terms of 7 and 8 hours. This means that the effects of these drugs last for a longer time. So are also the side effects, and they can be found in urines in terms of days. In conclusion, in this topic we spoke about the pharmacokinetics, the basic aspects, the most important parameters, and the ADME cycles of exogenous substances inside the body. Then we specified the behavior, the pharmacokinetic behaviors of some drugs of abuse. We saw that in recent times we have the possibility to analyze different biological matrices and study in a better way all the ADME cycle of the different drugs of abuse. Thank you.